Welcome to the second discourse session. And we will have 3 sessions. And the first one is on computational methods with Alban, Voppel, and Tang. So whenever you're ready, you can go.
Okay, so here I am again. You're not done with me yet. So I'll introduce the computational methods group, which has been co-chaired by me and Sunny, but Sunny's always longer than me, so give her the props. So our mission of the computational methods group has been to develop, harmonize, and validate computational methods for understanding these language and speech disturbances and psychosis. We have 26 members currently. Next slide will show them. We have regular meetings. Mail either me or Sunny if you want to be added to the mailing list. After shares or a few weeks after this, we'll send out a new email with a proposal for dates or when to meet again and continue these projects. So the current members, this is them. Sunny and me are at the bottom. The rest is in alphabetical order, I think, or ish, yeah. So what have we done the past 2 meetings? This group has been quite structured. Thanks for a large part to Sunny for organizing meetings, and more recently me, I did something as well. We inventory topics of interest and discussed them. We formed individual subgroups around specific topic areas and tasks. We identified the leadership of these subgroups and members and roles, and we registered these on a shared drive. I'll stop talking after a bit, so the 3 subgroups that have made some meaningful progress can shortly talk about their own goals and things that they did. So this is basically from our founding document. This is the first thing I already said. We'll make abstracts and we'll be circulating these around a larger working group and discourse in general for participating at different levels for data or analysis. This is the step where we're currently at. And we also interact with the other research groups. So we're quite related to the clinical harmonization group because they have data that we might want to use for certain things. And we do a speech bank and also the theory, for example. So this is a picture of our open to everyone Excel with different projects. There's data sharing, method stability, something else. There's a table here at the end. It's called abstract. And as you can see, it's still empty. So this is the goal for the next meeting, to start filling these. But if you look at the other ones, there's already like interested individual affiliations and a proposal. There's a preliminary subgroup coordinator and also common status deliverables. So if you want to join one of these groups, please interact with the preliminary coordinator, and they can add you and say what they've been doing already. So we have out of this list, we have 3 specific topics that we will talk about. And the first one is very similar to topic reports, topic modeling. Then we have cross-linguistic generalizability, and then we have vocal and acoustic biomarkers. So we'll ask some of these people that have helpfully send us some slides, and they can tell us in very short detail what they have done so far in our working group.
Yeah, no, the first we have here.
Okay, so it's me again. Okay, just a few slides. This is an ongoing activity. So we decided to start thinking about how we could model topics in psychosis. So before looking at actual computational model, we wanted to see what was going on out there. So we looked at the literature and we ran a very short and mini literature review. Let's say topic modeling is a kind of mathematical approach to extract latent topics in texts, which can be psychotherapy sessions or threads on social medias. It actually needs a lot of data to be computed, but it can lead to some interesting insights. So we looked at what was going on in the literature. We looked in IEEE database, PubMed, Embase, and other databases with that very short string of research. And what we found is that latent Dirichlet allocation is the most employed technique, is one of the oldest one, the first one, I would say. Now there are some other more new and relevant topic modeling techniques, but the most used is still that one. It's followed by the non-negative matrix factorizations and some other very interesting approaches such as the BER topic that we've seen in the presentation before. They are usually applied to corpora web script, such as, for example, social media discussion on Reddit and on Facebook, on Twitter. But there are some studies done on clinical records and very few studies on psychotherapy session. And the topics that they were able to identify, which seems to be relevant for this kind of research, so research in psychosis, are topics related to food, living situation, lifestyle, symptoms, treatment experiences, energy level, people, and family. So these are the main topics that seems to be quite transversal between the few studies that we've been able to read. And the future steps is to tackle some challenges that we see. So if we want to apply these techniques to data that we plan to collect in the future, we have to deal with some challenges, which some of them are the amount of data you actually need to compute topic modeling. You can't extract topics from a few interviews. You really need thousands of 10,000s of tokens to build something interpretable. And the other limit is the actual interpretability of the identified topics, which are not might not be easily interpretable. So these are computational technique. They tend to reduce the space of possible topics to a few most probable, most interesting topic, but they might not be that clinically relevant. So that's why we think that working with clinicians or people with lived experience might be very informative to interpret this topic. And we think that this kind of approach might be useful to, for example, model the temporal dynamics in people with relapses and prone to relapses in psychosis. So this is one of the possible application of topic modeling in psychosis. Thank you.
So next, Sylvia Ciampelli will talk about her work on speech graphs and the project that we're launching.
Yes, hello everyone. So today I would like to share our analysis plan for a speech graph subgroup. And for those of you who are less familiar with the methods, speech graph are network representations of a written or transcribed language, where each nodes represent linguistic units of various kind, and edges convey some information about the relations between them. So although the term speech graph is by now accepted in the literature of NLP and psychosis, maybe from a linguistic perspective, it is more appropriate to term them language graph, because language and speech are different. So language is the complex cognitive system that underlines verbal behavior, which includes aspects such as grammar and meaning, while speech is the medium of language, so is a verbal output. So that said, here I can show you an overview of the graph types that have been used and have been found informative about psychosis and its symptom dimensions across languages, actually. We have listed the main type of graph that have been used with different types of nodes and edge formation. Here we can see, for example, sequential relation, syntactic relation, different types of semantic relation, and referential relation or referential chain, which tackles, of course, different levels of language, from structural and syntactic level to semantic and pragmatic. We have listed the key NLP tools that are needed to build these graphs. and the computational sub-processes or pre-processing, depending on what you prefer, that are needed to ensure that the text is in the right format before the graph phase analysis. However, we don't know if features from different type of graphs correlate with each other in a given language, nor if and how the same graph produce consistent results across different languages. Because of this, in this subgroup, we would like to first map the availability of existing NLP tools for creating these different types of speech graphs within and across languages. Of course, it's possible that not all of the tools are available in all of the languages, or maybe they perform too bad in certain languages and then we cannot use them yet. We would like to standardize the graph quantification techniques, by which we mean to just provide a list of graph features that mathematically quantify this graph and that can be used systematically for this analysis across graph types and across languages. Then we also would be interested in comparing how these speech graph features relate to simpler NLP measures, such as sentence length and type token ratio, because it's possible that not always they are needed, and with a simple measure you could capture the same signal. Then investigate, of course, feature redundancy and collinearity within and between graph types. That's important. For example, if we think about prediction model, when of course we don't want features that are too correlated with each other. And then we want to see how strongly these graph features relate to psychosis and to its symptom dimensions. Of course, it would be interesting also to see which graph types correlate or explains which symptoms dimension the best. For example, we may expect that syntactic graph may capture better the cognitive dimension of psychopathology, while semantic graph may capture better the dimension of thought contents. So, and of course, the idea is then to repeat these across languages, so to see if these correlations with symptoms are stable across languages, with the bigger goal also to investigate which features may be universal, which of these graph features may be universally related to psychosis, and which instead can be more language specific and cultural specific features, features of psychosis. So this is, yes, thank you. Thank you for your hard work.
The next, Alberto is going to talk about his planned project on vocal and acoustic biomarkers.
Hi everyone, I'm Alban from University of Glen, but I'm also affiliated with the University of Turin in Italy. And this project is more focused with acoustic and prosody. And the idea here is that is to apply a linguistic approach to assess the generalization performance of acoustic and voice marker. Can you hear me?
Yeah, okay, yeah.
Yeah.
Actually further,
Yeah.
better, yeah.
Just unsure if you could hear me.
It's
So let's see. So the idea is that we can use a cross-linguistic approach to assess the generalization performance of voice and acoustic marker of schizophrenia, because we observed the publication of a lot of papers in the last year, considerable papers that found that we can use, for example, voice and acoustic features to reliably classify patients and control or to predict symptoms. But the problem is that we don't really know how well these models generalize when they are applied to different samples of two different languages. And this is crucial, especially if we aim to translational work. If we want to reach clinical applicability, we should be aware of how reliable, how robust how well this model works if we apply to different setting, to different conditions, to different ethical groups. And so the aim of the project is to explore how well this acoustic pattern and especially voice-based, acoustic-based machine learning models generalize across languages. This may be very informative for many reasons. For example, we could test specific hypotheses on how the difference we might expect across languages. For example, we know that in Italian, prosody has largely a pragmatic function, but in Chinese, there's also a lexical function. So we could make hypotheses on the mechanism. So if we assume that the mechanism underlying voice atypicalities is a motor disorder, we should expect that this manifests in the same way across languages. But if the underlying disorders is a social communication disorders, maybe this should manifest more in a more strong way in Italian. So this is informative. We can make hypotheses on language differences, but it's also informative because we can identify which features are more robust across languages. Or we can identify some bias. For example, in some recent work, we found that some models training on a language misclassify all the patients speaking a different language and classify all the other participants as either patient control. So I think it's really informative, both by a theoretical, but also a clinical perspective, because if you want to develop a clinical application, we should be aware of potential bias, risk, and also methodologically, this cross-linguistic investigation could tell us, for example, which are the methodological procedure, the model, the features, all these methodological aspects that are robust across languages and could also guide future research in this field. But of course, for this, we need a larger data set, we need multilingual data set. I think that the work of the Discourse consortium in this respect is outstanding. And so that's all. So if you want to join the project, please just write me. And there is also another thing, is multimodal model. So it's also would be also very interesting to put together a modality. So not just voice, but also text, and see how this could improve or affect the performance of the model across languages. Yeah.
Thank you. Thank you. As you can see, we've been a very busy working group. So that was not all. We actually have several more subgroups that have been discussed. So we didn't have slides for each of these, but actually Wolfram is here, and he's been involved with leading, I think, a measurement stability as well as a semantic space shrinking idea. So I just invite you to talk about those.
So we follow up by slides.
Yeah.
So on the one hand,
Yeah, you can sit as well. You also sit.
You were saving.
so on the one hand, we have unprecedented data, thanks to the Discourse consortium. And on the other hand, I think we are now in a position to approach these data in a slightly more hypothesis-driven way, so in a less exploratory way. And some of you may have seen the paper that Rui, who is down there in the back, has authored in Psychiatry Research, where against a long tradition, we have found a higher mean semantic similarity in schizophrenia. So we call this the shrinking semantic space. So on average, the concepts you are retrieving from semantic memory are closer together in semantic space. And to our surprise, this completely contradictory pattern generalized to 6 or 7 languages. In some languages, we have not found this pattern, but so it was like a null result. Well, that's enough.
I know. Well, no, we still have more.
But we have never found the opposite. And the latest results, I think, come from Turkish, from Emre's group. So there really seems to be something to that idea of the shrinking semantic space. And that does not preempt the question of higher perplexity at the utterance level. So we think these two things actually go together. If you are stuck in a shrunk semantic space, that can still mean that when you produce utterances that fit the context less, so the perplexity will go up. So this double pattern we are trying to show across languages, and so putting these two things together, I really want to test the generalizability of this basic new concept across basically everything we have in the discourse consortium. So this is the semantic concept, semantic generalizability topic that may also include some graph theoretical measures. So with Sylvia, we should talk about this. And the other thing is coming to know our measures better. So the topic of the stability of the semantic measures is the issue of whether when we measure the same person several times, whether our measures will actually tell us the same story about what's happening cognitively in that person. So for this, we need longitudinal data sets with multiple measurements, ideally dense measurements in patients and controls. And you have a paper on this already, so we are working on those data now too. And that needs to be really laid out in full detail to just check on the reliability of the measures.
I think that's great. Yes, thank you. Yes, I think I'm not going to go into detail about any of the other projects because I want to leave just a tiny bit of time for discussion. I think just this was the last slide. You know, as you can see, we're starting to form a lot of ideas. We're coming together and organizing. I think the structure that we laid out is very critical. The idea of registering abstracts and studies and disseminating that information across the discourse. So it's known who's working on what operations for collaborations are available. So we're going to definitely work hard on sharing those abstracts and making them, you know, organizing them. Lena, I assume you're going to talk at the end about our discussion about authorship and things like that. Yeah, so I'll leave that in terms of the structure there. I think, I think one other thing that wasn't, or maybe not clearly written out, was Nancy's question earlier on. And I think one of the other things made me think about the idea of a toolkit, where we are now and where we need to go. So we're not at the stage where there's like a single toolkit, I think, that's validated and generalizable that we can hand out. But I think we probably do have some intermediate possibilities that could be useful for this group. So I think that at least at this point, many of us, especially in this working group, have developed pipelines and tools. So if there are clinical colleagues out there who are interested and want to like use some of these methods and to think about them, I think many of us would be very happy to collaborate and to start like trying to apply some of these tools. I think this is how we're going to get to that like universal toolkit at the end, is to start with little things here and there and start trying to build upon the available methods that we have. So I think that that's also probably an important function of our working group, is to serve, you know, the colleagues who don't have as much analytical capacity.
So far now, it's been mainly about generalizability, stability, seeing what computational features like actually map onto something meaningful or like are stable or across languages. And then the idea is to comprehensively like collect those, define those, and then we will have like an end-all tool set ever, hopefully.
Yeah.
But so far, even if you have data and you don't really know what to do with it, this group has built a lot of pipelines, both in the acoustic, semantic, and syntactic level in general.
No, in fact, we might have to build like mini toolkits in order to execute some of these projects that we're talking about, right? Like particularly Alberto's project with acoustics, I think often sharing the actual recording itself is very limited. But even for transcripts and things like that, we might end up building like code packages that we can share with our collaborators where they can run them locally with relatively little, you know, minimal intervention on our part. And then share the de-identified process metadata. So I think, you know, just we're building up to that ultimate goal. I think that's it from me. Yes, thanks.
I think we have time for a couple of questions, and I saw some hands raising over there.
Let's do last year. Well, first I'll say it again. So surprising that the patients have increased semantic associations. That's like my a priori hypothesis. Like, why would it be? You said it was surprising to you. That's like, isn't that exactly like what one was said? Like, no, he didn't, he's English semantic association. Like, it used to mean the system.
But I think the way this has been understood always is that the semantic space involves associations can be formed, so the concept are necessary. And that's what early studies of the area.
I was interpreted as being an increase, like the whole Black Friday thing. And also don't forget, I would say, and what is that? They're very rated. They're not like super associated. So if you do like an associated normal class, then you're going to say boy, girl, something like that. But these measures aren't like that. They aren't like direct associates. So if you see an increase in semantic association, you're going to get those kind of indirect associations. So I guess I was just here. For me, it's very like that.
So if you look at the semantic line, eventually they have it. So
yeah.
I just want to give proper credits. Thank you for Maria.
No, yeah. I have a follow-up comment on this. I think it might depend on the task and what patients we're talking about. And depending on this, the semantic association can increase or decrease. But that's yes. With Chiara and Marta, the idea is to measure semantic distance across 3 different tasks to see if it goes in different direction, affecting accuracy. So it might depend on the task.
And also on your like unit of measurement or how, so it might contract or expand depending on how closely or how globally you're looking at it, right? And the language model and many other things.
So looking at the 5 words, unless you saw an abnormal, like by definition, these are very low to this. All of these semantic associated tasks. We get anything that's captured more than semantics have to go to top. All sentence embeddings, but those are very black box. You don't really know. But I know in our hands we haven't seen any increase in semantic association beyond 5 words. I mean, which is what you would expect because healthy adults don't use semantic associations beyond 1 or 2 words. Over and above lexicon.
Another thing that is also interesting is that some tests will not generate enough words to see some phenomenon. So the decrease of some associations could be like events that happen sometimes, two times. And it could be test dependent also as well. Not a tonic stuff, but something that has peaks and valleys.
Yes, so it's like global warming and versus climate change. So we stop calling it global warming. Yeah.
We have this differentiation between positive and negative thought disorder, which is very helpful. But I think within the domain of positive thought disorder, we can still distinguish between language reflecting disorganization, which we're usually looking at, but also language reflecting delusional thought. And I think that is particularly associated with the shrinking semantic space that Voppel has coined. And that could also be well captured with a thematic analysis. So many patients who are actively psychotic have a kind of preferred topic that can hardly be distracted from. And I think that could be reflected in shrinking semantic space in positive thought. Yeah, I think that would be positive thought model as well.
No, I was always taught, this is what, I was always taught that, delusion is a content of thought, so, and you would not pick up a general semantic reduction in semantic JP. We wouldn't pick that, and then we would not pick, that would be, you could look at the number of words related to a particular topic, but I don't think you would pick up something like what from, I don't think like separation, you wouldn't pick that up. So I don't think that, increased, LSA or increased virtual net would pick up on something like that. If anything, it would be decreased, but I don't think it's sensitive.